Good morning or afternoon or evening or wherever you are, and welcome to Chemistry Remote Learning Day number 1. We're continuing with Unit 6 today. We're going to be looking at chemical reaction and stoichiometry in this unit if you've forgotten. As a reminder, your slides are in Google Classroom under the title Unit 6 Slides. And so if after this EdPuzzle you want to refer back to them, they will be located there. So these are the links. Remember, you can click them to go to each one of the lessons, and we're going to start today with lesson 6.5 right here. Before we do that, I want to go through a couple of things about how remote learning is going to look for chemistry, a couple of reminders and things like that. So first of all, hopefully you have done your warm-up. It's going to be a Google form, and that will be the beginning of your lesson every day that we're stuck at home on the computers. And then you'll go over to EdPuzzle like you are hopefully right now. And during the EdPuzzle, I'm going to go through the PowerPoint as if I was doing it in class. After the EdPuzzle, you will always have some sort of assignment to do on Google Classroom. Today is going to be a simulator to look at balancing equations. You always have some sort of worksheet that goes along with that activity. The way you submit the worksheet is up to you depending on what your capabilities are, what your device you're working with, whatever is going to be easiest. They'll always be Google Docs, so you can either submit them via Google Classroom, just typing into the document directly like you would if we were in class, or if you want to print it out, if you have that ability, or if it's easier, you can answer the questions on loose leaf, take a picture or scan it and send it to me, or upload it as an attachment on the assignment. If you have questions about how to submit work and things like that, that is something that we can go over in office hours. Mine are going to be 3 hours a day, kind of in the early afternoons on Zoom. And then Ms. Distelhorst, who, if you guys don't know, she teaches with me on Tuesdays and Thursdays. She's going to have office hours for chemistry in the mornings on Tuesdays and Thursdays. If you want links to those or more information or specific times, always go look at Google Classroom on the syllabus I sent. That will have links to our websites, our Zooms, Hangouts, and our emails and all of that good stuff. So throughout the EdPuzzle assignments, you're going to have a few questions, kind of like the ones I would ask in class, like raise your hand if you blah, blah, blah. Those are not going to be graded for getting them right or wrong. You're going to get a grade on completion for those, so please just answer them to the best of your ability. They're mostly for you to see if you're keeping up with what we're learning in that slide on the PowerPoint or something. At the very end of the EdPuzzle, there will be a couple assessment questions which will be graded, and those are for me to see if you learned what you needed to throughout the lesson, or if I need to reteach something in a different way, or if a few students need extra help on some of the topics. Okay. But at the end of every lesson on Google Classroom, there will be links to more YouTube videos. This video will be up on YouTube if you want to refer to it later. Again, the link to my YouTube is in the syllabus that I sent out. But if you have any questions, please just send me an email if you need it. Okay? But let's get started. Today we are doing 6.5 balancing chemical equations. By the end of this lesson, hopefully you will be able to say, I can balance chemical equations to show conservation of mass using the smallest whole number ratios. You've already seen this to-do list at the end of your warm-up because hopefully you already did your warm-up. If not, make sure you do it. It says 6.5 warm-up. Do this first, so make sure you do it first. You're on the EdPuzzle. After this, you will do the PHET simulator with the worksheet, and then an exit ticket on Google Classroom as well. In terms of due dates, your warm-up and your EdPuzzle should be done within 24 hours of me posting the assignment. If you need extra time, please just let me know. I understand this is a weird time for all of us, so please, please, please just let me know. The simulator, a worksheet, and the exit ticket, those are going to be due before the next lesson is posted, so about 48 hours from the time this was originally posted. This is to give you time to check in with me if you need help, come to office hours, multiple office hours, and go from there, okay? So a little bit of review, the law of conservation of matter. You hopefully answered this in your warm-up correctly, but as a reminder, it is that matter cannot be created nor destroyed. We were looking at this before we went to remote learning, and we're looking at the mass. The total mass of the reactants must equal the total mass of the products. This is what you saw in your warm-up. If X grams of sodium chloride decomposes, how many grams of this and that, those types of things. Today we're going to be looking a little bit closer and not just looking at total mass, but rather the number of atoms. Looking at the number of atoms before the reaction and the number of atoms after the reaction, knowing that those two things must be equal. You can't start with 10 oxygens and end with 7. Where did those other 3 go? And so that's what we're going to be doing when we're attempting to balance chemical equations. So I'm first going to go through one that is already balanced so that hopefully you can see what the goal is when balancing these equations. So I have 4Na plus O2 arrow 2Na2O. In words, this would translate to 4 moles of sodium reacts with 1 mole of diatomic oxygen to produce 2 moles of sodium oxide. Now, what we're learning today are going to be about these numbers here at the beginning. This 4 before the Na, the 2 before the Na2O, and there's actually an invisible number in front of this oxygen as well. These numbers at the bottom, we've already talked about. The 2 comes from oxygen being diatomic. The 2 here comes from the +1 and the -2 after we crisscross. But now let's look at the numbers before these. These are going to be called coefficients, and they represent what is known as the mole ratios between the reactants and the products. 4 moles of sodium, 1 mole of oxygen, 2 moles of sodium oxide. Looking at this visually, I have my before and my after, my reactants and my products. I have 4 sodiums, so 4 moles of sodiums, 4 sodium atoms, either way I have 4 of them. I also have 1 diatomic molecule. Notice how these are touching, because touching, you remember, implies a chemical bond. And here I have a chemical bond, but it's between 2 sodiums and 1 oxygen. If I were to stop right here, you would notice we have an issue. I start with 4 sodiums, but here I only have 2. I start with 2 oxygens, but here I only have 1. That is what that number 2 is there in front for. Now I have 4 sodiums, 2 oxygens, and 2 oxygens. Okay, and that's what we're doing when we balance equations. We're going to use these coefficients in the front to show the number of atoms being conserved throughout the reaction. So I'm going to go through an example showing decomposition of water, and I'm actually going to be showing you guys this reaction real world and how you can see this molar ratio in action. I'll do this reaction again in our office hours this week, let's say on Tuesday, and I'll also walk you through how you can do it at home because I'm doing it with just common household objects. So first thing you want to do is you want to see if this is balanced. Look at the number of atoms before and after. So I'm going to start with hydrogens. How many hydrogen atoms are reacting? This is going to be a question you're going to ask yourself in your head. I have 2 hydrogens in my water molecule, and I have 2 hydrogens, part of the diatomic. Hydrogens were good, 2 before, 2 after. But when we look at oxygen, things get a little weird. We have 1 oxygen at the beginning because water is 2 hydrogens and 1 oxygen. And at the end here, we have 2 oxygens because oxygen is diatomic. Now, here's the issue. 1 oxygen at the beginning, 2 oxygens at the end. And where did this other oxygen come from? The answer is it didn't just appear. We're not showing the actual ratios that are occurring in this reaction. So what we're going to do is we're going to balance this. And you'll notice I have these blanks in front, and we're going to be putting numbers here to show a ratio where this is going to work out. Now, balancing takes a lot of practice. There's a bunch of different ways you can do it. As long as you get the right answer, I don't care which way you do it. I'm going to show you a mathematical way to do it. I'm going to show you how you can draw diagrams to do it, kind of like the last example with the sodium. But some students can just look at these and figure them out. And so depending on where you're at, answer them in whatever way you can. I recommend doing it on loose leaf, practicing, drawing pictures, whatever you need to do. So I'm going to draw the pictures first. I have H2O, which I'm going to use 2 circles and an X. Circles are hydrogens, X are oxygen, 2 hydrogens and 2 oxygens. Here you see the error where I have 1 oxygen before and 2 after. And so what we're going to do is we're going to figure out how we can multiply these groups, how many of these groups we need to show a conservation. Now I have 1 oxygen at the beginning and 2 at the end. So what we're going to do is we're going to multiply this by 2. Okay, and so I'm going to take this number 2. Sorry if the bottom of the screen is showing up for you guys. I'm going to take this number 2 and I'm going to put it here in the front. That means I have 2 times everything that's here at the end. Visually, I'm going to have 2 hydrogens and 2 oxygens here. And I'm also going to put little boxes around these because we can't change this ratio. 2 hydrogens to 1 oxygen, that's water. You can't change it. The most common mistake would be throwing a 2 right there to make 2 oxygens and 2 oxygens, but then it's not water anymore, okay? But now we have a problem. Hopefully you've answered that now we don't have conservation of hydrogens. This number in the front applies to everything after it. So not only did I double my oxygens, I also doubled my hydrogens. 2 times 2 to give me 4. And that's why I have these 4 little circles right here. So what do I need to do here? I'm starting with 2, and I need to have 4 like I have over here. These numbers are going to be multiplied, so I'm going to multiply it by 2 as well. Drawing it, I have 2 groups of 2 to show my 2 diatomic hydrogens. And from here, you could stop. How many hydrogens do we have at the beginning? 2 times 2 is 4. 2 times 2 is 4. So we have 4 pink circles before and after. How many oxygens do we have? 2 times the invisible number 1 to give me 2. And I have 2 oxygens here. Now some students will look at this and say, Miss, it's not complete. And so we can put a number here if you want. You don't have to, because remember, you have the right to be lazy if what we're talking about is the number 1. And if you look at the chart here on the bottom, you'll see that the number of hydrogens at the beginning equals the number of hydrogens at the end, and same for the oxygens. So the decomposition of water, to show conservation of atoms, we are going to balance it to say 2 moles of water decompose to produce 2 moles of diatomic hydrogen and 1 mole of diatomic oxygen. Okay, and so balancing, you can either draw these little X's and O's, you can do the math, or you can just picture it in your head. Here's what this looks like with actual molecules. I have, let me get my face out of the way. I have, how do I get this? There we go. I have 2 waters with 1 oxygen each, 2 hydrogens each, and they break down into these individual parts. As you can see, the total number of hydrogens before equals the total number of hydrogens after. So now I'm going to show you this reaction real world, and I'm going to show you how we end up with what looks like twice as much hydrogen as we do oxygen. This reaction you can do real world with stuff at your house, and I'll walk you guys through how to do that during office hours this week if you want. Hello, and welcome to Miss Garcia's phone. Today we are going to be doing an experiment showing the decomposition of water with the goal of seeing how many moles of hydrogen you get at the end versus how many moles of oxygen. To do this, you will need the following items. I have pencils. Notice how they're sharpened at both ends. I have a beaker of water. You, of course, could use a cup. Some 9-volt batteries. You really only need 1. Some normal salt, sodium chloride, and some sort of wire. You can use paper clips. I have these, of course, because I am a science teacher, but some sort of wire to connect the pencils to the battery. You also need some sort of piece of paper. This is just to hold the pencils. I've folded a piece of paper, but you can also just use an index card. Alright, so the first thing you're going to do is you're going to take your beaker of water and you're going to add some salt, pretty generous. And you're going to stir it. You can just use one of your pencils. They're going to go in the water anyways. And you want to try and get as much as the salt dissolved. The purpose of the salt here is to act as an electrolyte to allow electricity to flow better throughout the reaction. And what we're going to be doing is we're going to be using electricity to take the water molecule and break it apart into hydrogen and oxygen. And so what you're going to do is you're going to take your piece of paper. I've folded mine just in half so that way it's a little bit more sturdy. You're going to take the pencil and you're going to poke a hole through on top of the beaker of water, and it will sit in there. You're going to do the same thing with the second pencil to sit here at the top. Now you will notice my pencils were sharpened on both ends. You're going to want to do that because the pencil lead, which you guys hopefully know is carbon, graphite, is a semiconductor, meaning it will allow some electricity to flow through. Once you have your pencils in the water, they'll look something like this. And you're going to take your wires or your paper clips and you're going to connect one to each one of the pencils. You may need to kind of steady this. I'm using one hand to hold my phone, the other to do this, so it's a little bit more finicky. Okay, and then this is not going to be in shot, so I just wanted to show it to you. You are going to take your wire ends, they're connected to the pencils at the top, and you're going to connect one end to one part of the battery like this, and the other to the other end of the battery. If your battery is working, almost immediately you will be able to see some bubbles forming on the bottom of the pencils. Okay, and so these bubbles are going to be the hydrogen and the oxygen gas that are being produced. Now we'll learn why later, but it has to do with the positive and negative ends of the batteries. That one of these pencils is where the hydrogen gas is being collected, and one of these pencils is where the oxygen gas is being collected. In our balanced equation, we knew that for every 2 moles of water that decompose, we're going to get 2 moles of hydrogen and 1 mole of diatomic oxygen. And if you look closely at these, you should be able to see that one of these pencils is producing way more gas than the other one. This is because of the 2 moles of hydrogen produced here on pencil number 1 versus the 1 mole of oxygen produced here on pencil number 2. If you want to learn how to do this reaction step by step, you can come to office hours. I'll do it again. And if you do it, you may also notice something interesting happening when you lift the paper up. Okay, we'll learn more about this reaction in Unit 9, but for now, right now I'm going to go through a couple more examples. I'm going to go through these relatively quickly. If you want a further explanation on how to do these, I'm going to attach some extra YouTube videos that are going to walk through how to balance chemical equations, and the online simulator that you're going to do is going to hopefully solidify how you do this. So decomposition of calcium oxide, very similar. I have calcium oxide plus 2 minus 2 gives me a 1-to-1 ratio, 1 calcium because it's not diatomic, and 1 oxygen that is diatomic. Looking at this, we have an error. I have 1 oxygen and 2 oxygens at the end. So as you can see down here, I've already multiplied by 2, and I'm going to put that 2 here at the beginning. That gives me 2 oxygens to match my 2 oxygens at the end. But in addition, we also doubled the calcium. So you're going to say, how many calciums do I have before? 2 times invisible number 1 is 2. So I also need to place a 2 right here to account for the 2 calciums and the 2 calciums. Check your reaction. How many calciums do I have before? 2 times 1 is 2. After, 2 times 1 is 2. Oxygens, 2 and 2. You could stop right there, or if you need to finish it, we can put a number 1 to show the balanced equation. Or you can use the diagrams like I did before. You can either draw circles where you label them, use X's, O's, things like that. And if you notice here, with just 1 of each, it looks like an oxygen has appeared out of thin air. So I'm going to double the oxygens, but to do that, you have to double everything that comes with the oxygen. And that also doubled my calciums here at the end. Okay. The last thing you want to do before you finish is you want to ask yourself, the last part of the learning target was balance using the smallest whole number coefficients. Looking at your numbers at the beginning, 2, 2, and 1. Ask yourself, is this a balanced ratio? If this were a fraction, would it be simplified? The short answer is if you ever have a number 1, it's already simplified because you want to use whole numbers. You can't simplify the number 1 to anything smaller. But let's say a student accidentally wrote 4, 4, and 2. Technically, that would be balanced. 4 calciums, 4 calciums, 4 oxygens, and 4 oxygens. But the ratio 4 to 4 to 2 is not simplified, and that is something that you are expected to do to accurately balance equations. And so 4, 4, and 2, because they are all even numbers, you can divide them by 2 and get 2, 2, and 1. The last one I'm going to go through really quickly. I'm just going to prove it to you because this is the first one you will do on your PhET simulator. You will have 2 ammoniums here at the end to accommodate the diatomic oxygen here at the beginning. But now I have 2 times 3 to give me 6 hydrogens, so I'm going to put the number 3 here as well. Ultimately, this is already finished. You can put a number 1 if you would like, but visually, this is what it looks like. 1 diatomic nitrogen, 3 diatomic hydrogens give you 2 ammonia molecules, which is NH3. Mathematically, you can look here at the breakdown between nitrogens and hydrogens. All right, so from here, you are going to navigate to the PhET simulator. The link to this will be on Google Classroom. It's also going to be in the worksheet that you are going to be completing before our next lesson. I do want to show you just a little bit about how this works. When you get there, you'll see this screen. I'm actually going to go there right now. And you're going to be doing a couple of things. You're going to do the introduction. Your worksheet will walk you through it. To get started, I recommend putting 1 of everything here. You also have some tools available up here. You have a balance that shows you the atoms here, which may be helpful, or you have a bar graph here, which will show you if it is balanced or not. You then want to be able to go in and change these. Notice how changing this number changes the number of NH3 groups you have. Those would be like the boxes I was drawing earlier in the molecule. And you'll notice this has a cap to how many you can do, but you want to do it so that you end up with a balanced equation. And you'll get a beautiful little smiley face when you do. Okay, so as you go through this, there are instructions on your worksheet. I'm going to go back to the slides really quickly. And as you're doing this, there's a couple of things I want you to remember. You are looking to check the number of atoms before and after. You are welcome to draw the diagrams on loose leaf. I highly, highly recommend it. If we were in class, I would be giving you guys whiteboards at this time. So just use pen and paper, pencil and paper. You should always balance in pencil. And just see what you can do. When you check your answers, make sure your coefficients are in the smallest whole number ratios. And what I mean by that is just simplify like you would in math class. Okay. As you are working through this worksheet, it may be challenging for some of you. Balancing is something that just takes work and practice. And so if you feel like you need extra help or if you don't trust your answers, you should be coming into office hours today, tomorrow, the next day, or sending me an email if those office hours times do not work for you. Okay? But hopefully you have a good understanding about how to balance equations after these PowerPoint. This video is longer than the ones in the future will be because I gave you a little bit of how we're going to do this at the beginning, but they will be a little bit shorter moving forward. But if you have any questions, please just email me, reach out, and we'll figure out how to do all this remote learning together. Okay? Bye!